Many of the control functions are running on the onboard computer.
Seth is a guy who you never actually see in the videos, but he's in every single past video. There's been Seth or someone essentially doing Seth's job controlling the robot. And these videos that we've seen this week are the first time that this has really been demoed autonomously.
That's right. So, as I said, this is a platform. The arm is an extra cost option that you can take off. And that white box is a computer that really we're only using today because it's got a better radio than the standard radio. And in this environment where you all have cell phones and Wi-Fi, it's sometimes a challenge to get that working. So this is using a spread spectrum radio that makes it easier. The robot's omnidirectional. When it came out, it was using a number of different walking gaits. It's omnidirectional, so Seth can, just using a joystick, steer it around. And we'll have the robot out in the lobby after the talk, and if some of you will get a chance to
last video, there's been Seth or someone essentially doing Seth's job controlling the robot. And these videos that we've seen this week are the first time that this has really been demoed autonomously.
That's right. So, as I said, this is a platform. The arm is an extra cost option that you can take off. And that white box is a computer that really we're only using today because it's got a better radio than the standard radio. And in this environment where you all have cell phones and Wi-Fi, it's sometimes a challenge to get that working. So this is using it.
You know, my muscles in my leg don't look like a servo motor with harmonic drive, which is what a lot of robots use these days. There's a different...
Very stable. I want to emphasize that this is a fully open loop. There are no sensors on it. Even with open loop, it can walk very stable. Now, can you imagine by having an uneven closed loop, this will be able to walk on uneven terrain and do many, many things. It's not arms, because these limbs can be used for both locomotion and manipulation. We call this multimodal locomotion because there's many different ways. Oh, by the way, if you hear the sound, I don't know if you can hear it, this is not an internal combustion engine. When you do robotics research and development, you need to monitor a lot of parameters. In this case, you want to monitor the current. So we have a speaker. Do you hear it? Engine sound, that's actually the current draw. So as you can imagine, it can have a wide sprawl quadruped walking. So wide sprawl, stable but slow. Now, if you want to go really fast, it changes configuration to more like a dog or a horse, and you gotta walk with it. Don't make it go too fast. We don't have a lot of space. Okay? Make it go run this way a little bit. Dynamic quadruped walking. Good. Cool. And then we haven't implemented just yet, but we'll be able to do this and do a somersault kind of motion as you wheel. And if you fold this legs like this, it becomes more of a humanoid type bipedal walking. And of course, you lift this arms like this, it becomes like the Navi type of locomotion. Cool. Next time you took it out of the lab, so you're seeing it for the very, very first time. So it's not going to walk just yet, but I think it can stand up and do something. By the way, it's a lot of things happening. Okay, so let's make it stand up. Okay, as I mentioned, by software, it can change a lot of the parameters. Let's make it stiffen the legs, just to show you that it's a very stiff robot, which is more the conventional robots, right? But we can also change the compliance. Let's make it a little bit, give it a little more compliance. Okay, now it's compliant, right? See? And we believe that this is a breakthrough. So combining the bare actuator to see the jumping and these robots, this robot will be able to jump, roll, and do all these kind of crazy stuff, and we're very excited. Cool. I think we're running out of time. So.
It allows you to do anything you want, walk around up and down the stairs and ladders, drive a car and a bicycle. But as soon as you bend, as he does, it minimizes the forces at L5S1, so he's able to pick up heavier objects much easier with less strain on his back. We call that back X, and he can wear that all day long. And in fact, you can separate that very quickly if he wants to get out of it in a matter of a few seconds.
When you say L5S1, is that a vertebrae?
Yes, in the vertebrae joint, the very bottom, that's the place prone to injuries when you do such a motion. In fact, you just realize he took off the back X device itself, and what is left are the soft components that are basically interfacing him to the machine. That's one of the devices called back X. Showing a pair of legs, as you see here, and it allows him to walk around again, do whatever he wants to do. He's completely free, but as soon as he wants to. At the knee joint, minimizes the risk of injuries without any impeding factor on his motion. He can hold his hand this for a long time because the device helps him to lift subject and minimizes the forces at the shoulder joint and maintain that and reduces the risk of injuries at shoulder. These are actually, many of them are used in work in automotive industries.
Just to be clear, does it allow you to lift up more weight than you otherwise would be able to, or to maintain the same amount of weight from the heart?
Well, you can use them two different ways. If you use this device, then if you pick up 15 pounds, up to 30 pounds, it fills 15 pounds.
Okay.
So if you go back and add up the lost weight, then you go back to what you are. Shoulder X, as you realize, back X, and you can do all of those at the same time, and with feeling less amount of force. These devices are going to be used in many, many places, factories, and places that do repetitive motion to reduce the risk of injuries.
Okay. How much are the modules individually?
They're about like $4,000 to $5,000. I think they're in that range prices. This is a training mode. That's what you see. There is a voice on the computer that tells you what's happening. He's using two crutches to stabilize himself.